Hi guys, good morning. Welcome back to the next video. I hope that you guys are doing well and जिंदगी में फाड़ रहे होंगे या फिर जिंदगी की फोड़ रहे होंगे. Before starting, firstly, if you're expecting the video length to be short, then please you can go, because last time I saw that I showed you the bottom approach directly and many people could not get it. It's the reason I'll start from very scratch to actually the most optimized one. So for sure the length will go long. If you just want to actually, like, if you're good on this thing which I'm going to show, you can just skip and you can just move to the end. But yeah, before further ado, let's start with the problem statement itself. It is saying, okay, profitable schemas. So we have a group of n members. We have a group of n members, which means n peoples or members are there with us, and a list of various crimes that could commit, which means n members and a list of crimes. ith crime, it generates a profit pi, which means we are having the array called as profit. We have an array called as groups and require group of I members. To actually execute the ith prime, I require group of I people, and the profit earned after executing that ith crime will be profit of I. It is saying if a member participates in one crime, that member cannot participate in another crime. Okay, cool. Let's call the profitable schema and as any subset of these crime which generate at least minimum profit, which means out of all these crimes I generate a subset of some crimes, and that crime has profit combined more than the minimum profit, and the number of members in that particular crime which I choose, number of crimes which I choose, the number of people, it should be at most n. So that particular subset of crimes is a profitable crime schema. We have to find the number of such schemas, which is profitable crime schemas, that can be chosen. Since the number can be pretty large, which means the number of such subsets can be pretty large, so I have to return modulo 1 plus 7, which is standard modulo because it's a prime number. Now, firstly, you got, okay, ith crime. If you execute that, the profit earned will be profit of I, and the people, member in that crime will be group of I. Cool. Let's look at the first example itself. It's pretty easy, pretty standard. We have the group, which means the crimes are 2, first crime and second crime. For the first crime, number of members are 2, second crime, number of members are 2. First crime, the profit is 2, second crime, the profit is 3. What my condition is that my minimum profit should be 3, my maximum number of people at a time should be 5. It should not go more than 5. Cool. Let's see. First case is, okay, I have one crime committed, which means I just have this particular one crime, which means members are 2, profit is 2. Profit is 2. I want the minimum profit as 3. It is not a condition which is satisfied, so it's not a good case. Cool. Next day, okay, I have one crime, but now the crime is the second crime. Second crime, okay, cool. Second crime I got, members are 2, profit is 3. Profit, I wanted minimum profit to be more than equal to 3. Okay, profit is done. A number of members are less than 5. I wanted like less than equal to 5. It is done. It's a good profitable schema, which is, I just add, okay, one schema I get from here. Another option can be I execute both the crimes. Number of members in total are 4, and 4 is less than the number of members allowed, which is 5. Profit earned will be 5, which is actually more than 3, which is the minimum profit which we need to earn. That's the reason I can just say, okay, it's also a profitable schema. Number of profitable schemas in total are 2. Thus, the answer is 2. Same goes for the next example. In this, all the schemas between all these subsets, if I have 1, 1, 1, if I have both of these two, both of these two, both of these two, or I have all these 3, all these are profitable. You can see in the example. So firstly, very intuitive brute force solution which comes in our mind is that, okay, I'll generate, see what I wanted was, it says, it itself says a profitable schema, any subset of these crimes. So why not generate all these subsets, generate all the possible subsets, check which one is a profitable schema. How to check that profitable schema? It is a condition which is said, okay, that if we choose a subset, the sum of profits should be more than equal to minimum profit, and the sum of groups of I should be less than equal to my n. So I just apply this condition on every of those subset which I generate, and thus I can find the number of profitable schemas. But to generate the all subsets, let's say if we have n crimes committed, so I can generate 2 raised to power n, or let's say n is already there, so let's say x is the number of crimes committed, so I can generate 2 raised to power x subsets, which is 2 raised to power 100 for this problem, because x, number of crimes, which means number of profits, are actually nothing but 100. And if you don't know how we choose this 2 raised to power 100, because for every crime we have 2 options: to commit that crime or to not commit that crime. It's the reason we have 2 raised to power 100 possible subsets which we can generate. But generating these many number of subsets itself is not possible. So that is not feasible. But do you heard what I said? How we generate these subsets? For every crime, we have 2 options: to grab that, which means to execute that crime, or to not execute that crime, which means I have, okay, let's say I execute this crime, so it's done. While in the other case, I do not execute this crime, so it is not included, which means the profit will not be included and the group members will not be included. In the other case, if okay, it is done, it is taken, done. Next option, for the next pair, which is the next crime, I have again 2 options: execute that crime or not to execute that crime, which means execute that crime or not to execute that crime. Cool. For the next option also, for the next crime also, I have 2 options: execute that crime, not execute that crime. Same, execute that crime, not execute that crime. You see what happened? Can you just recall of something you have heard of, something like this? If you have some of the options, at every options you are just going and checking, can I take it, can I not take it, can I take it, can I not take it? Don't you remember of 0-1 knapsack? Shall I grab this ball? Shall I not grab this ball? Shall I put this ball in my sack? Shall I not put this ball in my sack? Remember, it's the same thing. It is exactly the variation of a 0-1 knapsack problem, in which I have to choose, okay, shall I choose this crime? Shall I not choose this crime? Shall I choose this crime? Shall I not choose this crime? And thus, I can get the number of ways I can choose my profitable crimes. Let's see how will it happen. Let's say if I am standing at the X crime, or let's say the 3rd crime right here. So I have 2 options: execute that crime or not to execute that crime, which means if I execute this crime, so basically the effect, which means the profit will be added and the number of members will be added. But I also need to get, okay, what is the result of the before part, which means I need to find, okay, what is the profitable number of schemas up till this point. At the point 3, I am saying, okay, shall I execute this crime or shall I not? If I execute or if I not execute, in both ways, I want, okay, what is the number of profitable schemas up till this point, up till the point right here. It is nothing but a 0-1 knapsack problem, which I am actually showing you how 0-1 knapsack works. If you actually know that, it's super fine. But if not, then actually it is how the 0-1 knapsack works. If I am at this point, I just see, okay, I can have 2 options. But if any options I choose, anyway, I just want what is the number of profitable schemas up till this point. So if I not choose it, if I choose it, if I choose it or not choose it, anyways, I need to add both the options, because I have to execute both the options. At every point, I have 2 options. I have to execute both the options because I want to go at every possible subset. Thus, I just add the sum of, okay, not choosing it and choosing it. That's the same thing which we have to do, which means as what I spoke, that I just go on to every crime. Right? Every crime means how we know. I just say, okay, we have K crimes. How we say K crimes? Because the profit length and the group length are both same as in the question itself. Profit length. Okay, I'll just, like, you can see profit length here. profit length and group length is both same, and it's actually the crime length. How many crimes will they execute? I named in my whole problem the crimes, number of crimes will be named as K, which is actually nothing but profit dot length or the group dot length. Here you will see at every executable crime, I have to choose of one thing. You saw one thing. Ith crime generates a profit of Pi, requires group of I members. The condition of profit of Pi is there because the profit sum should be less than equal to the minimum profit. Sorry, should be more than equal to the minimum profit, and the group of I, which means the sum of members, should be less than equal to n. It should be more than equal to, which means the sum of these profits should be, the sum of these groups should be less than equal to n, and the sum of this profit should be more than equal to minimum profit. It is a condition which I am saying. Okay, so for these groups, I need to choose I members such that their sum of these I members should be less than equal to n, and the profit I need to choose such that the profit is at least j, which means ultimately I want, okay, it should be at least more than equal to minimum profit. I, which is actually, I have to evaluate n members. Thus, you can easily see how my condition of EP itself is made. I am going on these K crimes. At every crime, I have to choose, okay, think of I members, and for those, I have to think of my profit as J because the condition is on members, condition is on profit, and actually I have to go on to every crime. That is how I will make my state of DP, which means execute first K crimes because I'm moving from left to right to execute one crime one by one. First with the I members and at least J as profit, because ultimately you saw what happened in the problem, what was written. At least minimum profit we need to choose. So ultimately I can just return about, okay, apart from J, I just put a minimum profit and I can just return my DP. You saw how the DP state is made because what was required. Your crime, because you are iterating on the crime, you have the condition on members, you have the condition on the profit. That's the reason. The code is pretty simple, exactly the same how we do a knapsack problem, although I showed you above also, just two options, grab it or not grab it. Let's see the code pretty quickly. Firstly, as we saw, our state of DP, which is K, I and J. K is nothing but the profit dot length, which I showed you is the group dot length, which is actually nothing but 100. I is actually number of members. In total, the members can go up to n because n is the condition, upper limit of members. So I just say, okay, my n is less than equal to 100. If you will see minimum profit condition, because I just want, okay, my profit should reach n and I am. My profit should reach minimum profit and I am good. I'm not concerned about the profit beyond minimum profit. As soon as my profit reach minimum profit, I am good. That is the reason I just put, okay, minimum profit is 100. I just put this condition. Now actually my DP recursive condition starts, which means firstly, as simple as that, K, I and J, the conditions I showed you above, it's nothing but same, which we told how it is done. Firstly, we have the base condition. Base condition, how it can be done? If I have executed all my crimes, which means my K is equal to my profit dot size. Now, I have to make sure that whatsoever profit I have earned so far, which is J, whatsoever profit I have earned so far, it should be more than equal to minimum profit, and whatsoever my members in total have been there, it should be less than equal to n. If it is the case, then I have to return a 1, else I have to return a 0. Or if my size has not, which means my K is not equal to n, which means it has not reached, but my actually members, which means I is the members right now, it's in total members right now, if it has already surpassed my allowed number of n limit of members, then I have to return a 0, because it's of no point to actually go on to the more members, because as we go on to the next crime, my members will actually increase. So it's of no use to actually go on to the next crime when my members have actually been surpassed my n limit. Now, actually what you do in your memoization, just have this dp array if initialized to -1, if it is not updated, so I can, if it is actually not -1, which means your value, you have reached the particular state right here once in your lifetime. If yes, then just return that state. If not, then I have just two options, as I told you. I'll execute that crime or I will not execute that crime. If I execute that crime, if I not execute that crime, if I not execute that crime, which means if I am on the kth crime, I don't execute it, no worries, move on to the next crime, which is the k plus 1th crime, because I'm starting from the 0th crime. So I just move on to the next crime, which is the k plus 1th crime. Now, as I am not executing this crime, so the members will not increase. So I will remain same, which was existing number of members, it will remain same. And as I'm not executing this crime, so the profit will also not increase. Profit remain same. Thus, I will just go on to the next of my crime. What if I execute this crime, which means I include this crime in my actual crimes? Then what will happen is, cool, you will just go on to the next crime, but now the number of members will be nothing but you grab, okay, what is the existing number of members plus the members of this kth crime which you did, which is the group of k, and also what is the profit you will get? Profit will be nothing but profit of k, which is the profit right now, plus the existing profit which you had, which was j. It is the profit, new profit which you will get. I'll just show you why it is minimum, but yeah, for now, just remember, it is the new profit which you have to get. And then rest of the things are exactly the same. Now coming on to why it is minimum, it is because I just said earlier also, I am just concerned about this minimum profit. As soon as it reached minimum profit, I am super fine. I don't have to worry about more profit than that. Aryan, why to consider this case? Okay, I know that you don't worry about the profit more than the minimum profit because you ultimately want to reach the minimum profit, but still, why to put this condition like this? Why to actually, just increase your like writing code part? I'll say it is because if you will see, if it is j plus profit of k, then what can happen is this j plus profit of k, it can actually go up till the length of 100 into 100, because j can actually go into the length of 100, and actually your profit of k, it can actually go into the length of 100. So if you have not put the cap of this 100, so this 100, because it will just add and can go up till the length of 1000. It's the reason you have to put a cap, because else the space will be so much that it won't be feasible. It's the reason, although if it would have been a lesser values, you could have put it, but it's good that you just put a cap of this minimum profit, because it is actually what you wanted, and else the space will go a bit large. Ultimately, when you have executed both, which means included the crime and not included the crime, then you can just add both the possible values. It's just mod addition which you have to do. I hope that you guys know this mod addition. It is just doing a mod every time we do a operation, which means add, subtract, multiply, divide, anything. Ultimately, I just stored it in my this dp state, and here is just the actual main function where you actually do a memset of this dp by -1 to actually say, okay, now the dp is being initialized, and ultimately calling this recursive function. The time complexity is nothing but O of k into I into j. As you actually can see, you are going on to every of those dp states, which is k, I, and j, indirectly in your recursive calls, because as soon as any of this state is done, it will just be returning back because of this of my condition, which will actually return back. And as you know, the k is nothing but profit.length, I is nothing but my members, in total it can be n, and j is nothing but minimum profit, because it will go up to 0 up till minimum profit. And same is the space, because you can see my dp of space was k, I, and j. That's it. Now, okay. You saw the dp approach, you saw, okay, now it would be good if you just wanted to solve this problem, it's good. But to actually optimize this, as I said, to optimize a problem, you can like rarely optimized in the recursive code. You have to go on to the iterative approach to actually optimize this problem, which means now we will see the bottom up solution of this same, exactly the same thing what we saw in the memoization. We will just implement the same, exactly same thing by our bottom up approach. Let's see how. Exactly the same thing, exactly the same thing, which means firstly I have this DP of this whole vector. Then I did exactly the same thing. I just moved on to the every of those crimes. See, every of those crimes I just moved on, grabbed, okay, what is the number of members which I will include right now because of the kth, because of this kth. See, here k says, okay, first crime, but first crime is actually the 0th crime because the indexing is from 0, right? It's the reason I just extracted k minus 1, which is actually the first crime itself. Now it will just say, okay, what is the number of members which will include because of this crime, and what's the profit which will include because of the crime right here. Then you will see that I just move on to the members, which means moving on to I members, because see, you saw now what happened in our DP. We had K, I and J. Moving on to all the crimes, moving on to the members, moving on to at least J as profit. Now moving on to my profit, as I said, upper cap is of minimum profit, because after that I don't want to go itself. No, yeah, that's the reason I have my J moving from 0 to the minimum profit. Firstly, one option is to not include that crime, which means my new state, which means EP of K, I and J is nothing but EP of K minus 1, which means I have not included the kth crime. So the results, the number of values will be exactly the same as of the last crime itself, because I am standing here, I have not included this crime at all. So whatsoever value I have got so far from K minus 1, it's exactly the same. I'm not included the crime. While if I include this crime, I have to one thing make sure that my number of members should be more than equal to my this. Why? It is because what you remember is that right now in this particular crime K, we have G members. So the number of members remaining would be I minus G, which I have to go and look for in the last of my iterations. If I minus G members are remaining, I have to make sure, okay, I minus G should be more than equal to 0, because I can't see for negative number of members. So I minus G should be more than equal to 0, which means I should be more than equal to G. Thus, I put a condition, I should be more than equal to G, to actually go and look at the before members, if it is the case. Then, to grab this kth crime, I just firstly, see, it is exactly the same thing. This thing is here, exactly here. So, it is just not including that kth crime, and here is the part of including the kth crime, which means if I included the crime K, then my G was good, it was happened. So the remaining members will be I minus G, and we checked this I minus G will for sure be more than equal to 0, because it's the reason, because we did not want to access the negative of my index. Now also I have executed my P profit, so the profit which I have to look for in my DP would be J minus P, and for sure it's also same that I don't want to execute that for negative. That's the reason I just took, okay, it should be more than equal to 0. It's the same thing that I just wanted. Okay, as soon as I reach my profit which is required, the bound profit, which is the, see, I just required my bound profit as J. J should be the profit which I am concerned of. Let's say it is the J. J is the profit which I am concerned of. If my P is the profit which I am earning right now, it is more than that, good. I don't have to worry about the remaining part. But if it is less, then I have to worry about the remaining part, which is J minus P. It is the thing that I just did, because it is how of what I'm concerned about. I'm concerned about only my profit up till J, because I just want, okay, at least J as profit. And after that, I don't want it, because my J is done, I'm good. So it is J minus P, and if my P exceeds my J, which is the minimum, at least my, because I required at least J profit, if that at least J is done, then I can just say, okay, whatsoever I have for 0, I'm good. Now the part of iteration of is done. Ultimately, I just have this sum of every of those. What happened? Of those, because see, ultimately my aim was how, see, firstly the TP state, it says first k crimes with I members and at least j profit. My question says to me, I want for at least minimum profit, so I just put, instead of j, I put a minimum profit. And it also said that I have to consider all the crimes, which means, okay, I have considered all the crimes whatsoever will be the case, I included, not included, I've considered all the crimes. So I've considered all the crimes, which means group या फिर our profit dot size. But always grab for all the members, which means from 0 to n. I will just grab, okay, if I have member 0, 1, 2, 3 up till so on. That's the reason I just grab the minimum, at least minimum profit, all the ways to get my actual ways which are profitable schemas. Same complexity, exactly same everything, because we are just transferred that recursive memoization code to actually iterative code. We're moving k, I, j, same, k, I, j, exactly same, k, I, j, and space also exactly same. But now to actually go on and look how to optimize that, if you just carefully look at one thing in the previous code, was to access my k, 3p, kij, for this k, I am always looking at k minus 1, which means at a particular point of time, I am only concerned about the last state and nothing more than that. Which means I'm only concerned about my last state and nothing else. That's the reason I can just eliminate that. I don't want the last case states. I just want the last state itself. So just eliminate that thing, which means ultimately I can just have my INJ and nothing else. The code will remain exactly the same. It's just that my k and k minus 1, this whole part of 3D array of DP will just get reduced and it will become a 2D DP array. By just exactly same thing, INJ, I minus G and max of J. It was exactly the same as you saw above. But one thing you need to make sure that your INJ will actually, see, earlier you saw one thing, your INJ were increasing because as a recursive call, it just increases. As we saw, your J was also increasing, which means your TP array, it was filling up from top to bottom, because I was from 0 and J was from 0 up till I up till n, J up till minimum profit. So it was moving like this, right? But I will say that in this condition, when you are eliminating one dimension of your DP in your knapsack, you have to go from right to left, which means now your I will go from right, your J will go from bottom to top, which means ultimately you will iterate on your DP from bottom to top in this manner. Earlier you were iterating like this. It's reverse. Oh damn. Earlier you were iterating like this, from top left to actually bottom right. But now you have to iterate from bottom right to top. I'll show why. But firstly, let's see the code. It's exactly the same, just that a dimension of my whole DP is reduced. My K, exactly the same code. It's just that firstly I told you I have to go from my right to left, which means earlier I was going from my N to, which earlier I was moving from my 0 to N. And see, you saw, right, your I starts for sure from G, so I can just start from G itself. From G to N I was moving. Now I will move from N to G. And also you saw that in a previous code you move from 0 to minimum profit. Here you will see you're moving from minimum profit to 0. Reverse. I'll show why. And exactly the same part, I to I minus G, J to J minus P, exactly same. And lastly the sum, exactly the same, just that K thing is removed, exactly the same thing. Now you will say, Aryan, you are having this from right to left, which means your grid will actually go from bottom right to the whole top. Actually, you iterate in a DP from whole top to right, whole top to bottom like this. But right now I'm saying no, you have to go from bottom right to the whole top. It is because if you actually go on from the top to the bottom, then one dimension is actually being reduced, which means in the last iteration whatsoever you were having, you can actually override that condition, which means I'll just show you. If you have the old code, which means if you had the k equal to 1, firstly I have showed you that okay, your k equal to 1 is, see, a 3D matrix or a grid is nothing but multiple snapshots of 2D grids, right? Exactly the same. Cool, no worries. So I've just, okay, it's a one snapshot, next snapshot is this, next snapshot is this. It is how a 3D array is made. So for k equal to 1, I just have all these members, I have this j profits. Cool. For a k equal to 2, let's say I am finding my answer for k equal to 2. I am standing at this condition, which means my k is fixed right now. K is this. I am concerned, okay, right now I have, because of this condition, I have my G members, because members, let's say, are G, profit is, let's say, P right now. So when I was thinking of concerning, wait a second, where is the code left? Yeah, I was concerning about k minus 1, which means if my k is 2, I was concerned about the first k and also I minus G and J minus P. Now let's see back. I minus G, see, if it is G, it is my J, sorry, yeah, I minus G will be like backwards and J minus P will be top. So I'm concerned about the location right here of my k minus 1, of my k equal to 1, which means I'm concerned about the location right here. For this, I'll again mark, for this location right here, I'm concerned about the location right here of my k equal to 1. For k equal to 2 of this location, I'm concerned about k equal to 1 of the location right here. But when you are actually iterating on your whole grid of DP, for k equal to 2, if you actually go on from top to, from bottom to top, so you are iterating like this from right to left, from bottom to top. So if you are actually concerned about the condition right here, you actually need your condition from this point as of state k equal to 1, which means the last state, which means not the k equal to 2 state, but k equal to 1 state. It was actually the last state, which means that in the last state, in the last iteration, it would have gone something like this. So it would have filled my whole array with pink at k equal to 1. If I'm again filling my array, let's say in the next step, I'm again filling the same array, but now it is being filled by blue. It is overriding my pink. So I just want, okay, it is being overridden as blue. So at this point, I want the concerned pink value rather than the blue value. If I would have iterated from the top, then I would have actually overridden that pink value, and at this point of blue value, I would be grabbing that blue value itself rather than the pink value. It's the reason I just iterate from bottom to top. Please remember that, because it is a standard trick to reduce one dimension in your knapsack problems. The complexity is same because you are iterating from k, I'll just show you, k, I and j, but the space is now reduced because your k is no more needed. I hope that you guys got it. Memoization code, bottom up code, and the bottom optimized code for all the languages, Java and Python, is down below. I hope that you guys got it. The video, I tried to make it as short as possible. It could go actually up to 1 hour, but still I just tried to finish that into 30-35 minutes. I hope that you guys liked it. It was the best problem of knapsack I have seen so far, like legit. If not the best problem, I don't think that if you like, you can learn anything better than this from knapsack. You learn so many good things, how you actually reduce one dimensions, why you actually move from back, not from top, how you can actually use the same state of matrix again and again, same array again and again, how you actually think from start, okay, we have to choose an element, not choose an element, relate that with an knapsack problem. that was a beautiful problem. It was standard, easy, but to actually code was actually a nice part. I hope that you guys got it. Aryan Mittal signing off. See you next time. Until then, goodbye. See you guys in the next video. Until then, goodbye. I don't know why I just wrapped the end part, but yeah, cool. Bye. If you guys like it, then please do the like button and share with anyone you want. Else, bye bye.